Hello, so right now we will solve this example problem. Show that the equation x minus c1 quantity squared plus y squared equals c2 is a solution to the differential equation y d squared y over dx squared plus quantity dy over dx squared plus 1 equals 0. We will be proving that this equation is a solution to this one. We're trying to find out if the derivatives of this differential equation will be taken out. One of the forms of the non-derivative equation will be this one. So again, we have here x minus c1 squared plus y squared equals c2. We have here two constants, and like I said, we have here two arbitrary constants that would be equivalent to two differentiations. Okay, so let's start differentiating this one, the non-derivative equation. So the derivative of that would be 2 times x minus c1 plus 2y times the derivative of y would be dy over dx equals the derivative of c2 is of a constant is 0. Dividing both sides by 2, that would be x minus c1 plus y times dy over dx equals 0. Okay, so now we have dy over dx is equal to negative x minus c1 over y. This would be our equation 1, which we are going to substitute to the differential equation so that we can see if we will have an identity equation. So we have found the first derivative. Then how about the second order derivative, the d squared y over dx squared? So actually, you can use this equation to find d squared y over dx squared, but as you can see, we have here a fraction, and if we are going to differentiate this, we are going to use the quotient rule, but it's a bit difficult. And if you can see, this equation is just the same as this one. So actually, we can use this equation to get the second derivative. Okay? So differentiating that, then what would be the answer? Differentiating that, we can get for the second derivative, that would be 1. The derivative of this would be 1 minus 0, or that's simply 1, plus, following the product rule, that would be the derivative of y dy over dx would be y d squared y over dx squared plus dy over dx times the derivative of y, that is y over dx2 equals 0. Then let's make this more beautiful. This would become y d squared y over dx squared plus dy over dx times dy over dx, that would be dy over dx quantity squared. Okay, so observe class, this is not the same with this one, okay? This is a second derivative and this is a first derivative that is raised to 2. Please take note of that. Plus 1 equals 0. So as you can observe, this differential equation is the given of the problem. It's the given of the problem. So right now we do not have to substitute this equation 1 to the differential equation, because we have end up that when this equation is differentiated twice, it results to the differential equation, which is this one. Therefore, this equation is a solution to this differential equation. So this is an easier way of proving a non-derivative equation as a solution to a certain differential equation. So that's it. Thank you for watching.